Hello everyone, my name is Harika, working as Assistant Professor in Marri Laxman Reddy Institute of Technology and Management. In this session, I am going to discuss about process concepts and threads in operating system. Here are the key points. In this, I am going to discuss about process concept and process state and PCB, that is process control block, and threads and its types. Coming to process concept, actually the process is nothing but the program during the execution, and that means during the execution the operating system loads the program from hard disk to main memory, and it is called as process. This process includes program counter, stack and data section. Program counter is nothing but it has the address of next instruction to be executed, and stack stores the variables and function calls, and data section contains the data related to the process. Coming to process state, as a process executes, it changes its states. So here the states are new, ready, running, waiting and terminated. New means the process is being created. In ready state, the process is waiting to be assigned to a processor, and running state, instructions are being executed, and then waiting state, that means in that the process is waiting for some event to occur. And terminated, the process has finished the execution of that process. Here the diagram of that process state. When the CPU when processes enter into the CPU, then that process will be initiated at new state. Then after, it will be assigned to the process at ready state. After assigning to the processor, it will go to the running state. At running state, the process is to be executed. While executing, if it is having any error occurred, then it will again come back to ready state. After correction of error, it will again go to the running state. So while execution, if the process has to be wait for an event, if the event is occurred, then it has to wait for the event at waiting state. After completion of that event, it will again go back to the ready state for assigning to the processor. Then again it will go to the ready state to running state for the execution. After completion of execution, it will exit at terminated state. This is the states about the process, and here this is the diagram of that. Next topic is PCB, that means process control block. It is also called as task control block, and it is a data structure that is used by the operating system to manage or control the processes. It contains process state that may be, new, ready, running, waiting or terminated. And next, process number is nothing but the ID of that number of that process, that means unique ID. And next, process counter. It contains the address of the next instruction has to be executed. So it is having the address of the next instruction to be executed. Next, CPU registers. In the CPU registers, it contains accumulators, stack pointers and also some general purpose registers. And next, CPU scheduling information. In this CPU scheduling information, it includes a process pointer and pointers to scheduling the queues. Pointers to scheduling the queues. And next one is memory management information. It includes the page tables and also segmentation tables. In this, page tables are there and also segmentation tables are also there. And what about account information? In the account information, it includes the amount of CPU used and the time limit and also the number of jobs or number of processes information will be stored in this account information. And next, IO status information. That means it includes the list of IO devices, that are allocated to the processes. The list of IO devices that are allocated to the processes. This is about the process control block. And next, coming to threads. Actually, the thread is nothing but a lightweight process. Thread is nothing but a lightweight process, so that it is having limited number of processes or limited number of tasks to perform, and thread is a basic unit of CPU utilization, and it comprises thread ID, program counter, register set and also the stack. Thread ID is nothing but the unique identification of that thread, and program counter is having the address of the next instruction to be executed. And next, register set, it holds the data temporarily. Register set holds the data temporarily. And stack, it stores the local variables and also the function calls. Stack stores the variables and also function calls. Next, multi-threaded processes, which means many software packages are multi-threaded. For example, if you take example as a web browser, you are taking the web browser as an example. In this, we are going to search for something. We are searching. So, for example, if you search about Mlritm, then it will gives the results in the form of text and also in the form of images. So, here the images will be, that means the images display by the one thread. The one thread displays the images and the other thread displays the text to retrieve the data from the network. Okay, like that we have word processor also as an example for this multi-threaded processes, because it is having several number of threads to control the process. Whereas coming to single and multi-threaded processes, here this is single threaded process and this is multi-threaded process. In these two processes, we have code, data, files, registers and stack segments. These are the different types of segments in the process. Okay. So, in this first in code segment, what will be there? Instructions, number of instructions to be stored in the code segment, and data, the global variables are stored in the data segment. And files. In these files, the open files which are the files which are opened, those open files are stored in files segment. And what about registers? Accumulators and stack pointers and general purpose registers. Register segments having accumulators, stack pointers and general purpose registers. And stack is having local variables and function calls. So in this data, in the data segment, global variables will be stored, and in the stack segment, local variables will be stored, and also the function calls will be stored in the stack segment. So whereas coming to single threaded process, these segments will be same for the multi-threaded process also. And when we discuss about single threaded process, this is nothing but a process is having a single thread. That means in this, the process is having single thread. If that single thread is there, so if that thread is blocked, then the entire process will be blocked. If that thread will be blocked, then the entire process will be blocked. Whereas coming to multi-threaded process, if one thread is blocked, then there is no issue for the remaining threads. The remaining threads will perform their task without interruption of the blocking thread. So that is the difference between single and multi-threaded processes. And here we have two types of threads. One is user level thread and second is kernel level threads. User level threads are managed by the user or application, and kernel level threads are managed by the operating system. In this, when we look into this diagram, in this kernel level, in the operating system, we have CPU. In this, it is managed by the operating system, and whereas user space, it is managed by the user or application. In this user space, we have thread library. Thread library provides programmers with an API. Application program interface for creating and managing the threads. Creating and managing the threads. The thread library provides the programmers with an API, application program interface for creating and managing the threads. In this, we have multi-threading models. Those are of three types. One is one-to-one. Okay, one is many-to-one, then one-to-one, and the third one is many-to-many. First one is many-to-one, right? Okay, whereas coming to many-to-one, that means many user level programs are mapped to the single kernel level thread. So, many user level threads are mapped to the single user level thread, which means the thread management is done in user space. So, this if one thread, when thread is, this is a thread, one thread, when thread makes a blocking system, then entire process will be blocked. So, only entire process will be blocked and only one thread can access kernel at a time. So, the multiple threads are unable to run in parallel on multi-processes, For example, Solaris green threads, GNU portable threads. Coming to one-to-one, that means one user level thread is mapped to another one kernel thread. So, that means one user level is mapped to one kernel level thread, like that remaining. So, if one thread is blocked, then there is no issue for the remaining threads. The remaining threads will perform their tasks as usually. For this, examples are Windows NT XP 2000 and Linux Solaris 9 and later. And the last one is many to many, means it allows many user level threads are mapped to many kernel level threads. That means in this model, the developers can create as many user threads as necessary, and the corresponding kernel level threads can run in parallel or multiprocessor. So, in this, as many user levels are created by the developer and also the kernel levels are corresponding kernel level threads are running in the parallel on multiprocessor. And for this example, Solaris prior to version 9, Windows NT 2000 with thread fiber package. These are the two examples for many to many model, and here are the references I have collected for this. Thank you.